Example 6, f of x equals x squared minus 9 over negative 4x minus 16. We're going to start by factoring. So the numerator factors to x plus 3 times x minus 3. The denominator, all we can do here is factor out a negative 4. So we have an x plus 4. We will talk about wholes. Zeros, which are the x-intercepts, vertical asymptotes, and horizontal or slant asymptotes. And then later we'll do our y-intercept if we can. So wholes occur when canceled factors are equal to 0. Well, no factors canceled, so we don't have to worry about that. Zeros occur when the numerator equals 0. So values of x that make the numerator equal 0. Well, that's going to be x equals negative 3 or positive 3. So we can just put plus or minus 3, and we will go ahead and graph those on our graph. Vertical asymptotes are values of x that make the denominator equal to 0, which is x equals negative 4. So we're going to have a vertical asymptote at negative 4. Horizontal or slant asymptote, we look at the degree of the numerator and the degree of the denominator. The degree of the numerator is 2 and the degree of the denominator is 1. And so the degree of the numerator is right here. It's this one. It's the degree of the numerator is greater. So we're going to have a slant asymptote at y equals mx plus b. So it will be a line, a non-horizontal line, where mx plus b is the quotient excluding the remainder. So we have to do long division. We actually take our original, so negative 4x minus 16, and we're dividing that into x squared, and I'm going to put a plus 0x because there's no linear term there, minus 9. And so we think to ourselves, what times negative 4x gives me x squared? Well, I don't want a negative, like I have to make it to be positive, so I have to put a negative here. I need to cancel the fourth, so I need a 1/4. And then this is just an x. I need to get to x squared, so I need another x. So multiplying that gives me an x squared plus negative 1/4 x times negative 16. So that's plus 4x. And then we subtract. When we subtract, we get 0. 0 minus 4x is, so we're subtracting the whole binomial from what's above, so that's negative 4x. We bring down the negative 9. And now we think, negative 4x times what gives me negative 4x? Well, that's a 1, so we put plus 1. And then we multiply. 1 times the negative 4x is negative 4x, and 1 times the negative 16 is negative 16. And we subtract. And so we get negative 4x minus negative 4x, that's plus 4x, which is 0. And then negative 9 minus negative 16 is 7. And that is our remainder. So we have plus 7 over negative 4x minus 16. So the slant asymptote is y equals negative 1/4 x plus 1. So this y equals this part without the remainder, because as x gets large, this fraction here gets smaller and smaller, close to 0. So it keeps getting closer to this line, but never reaches it. So we will graph that line as the vertical asymptote. So it goes through 1 and it has a slope of -1/4. So we go down 1, right 4. I do this in a different color. So it went through 1. I don't want to get mixed up with my graph. Down 1, right 4, down 1, right 4, or up 1, left 4. And that is the slant asymptote. And the slant or horizontal asymptote, they always help us determine what happens at the tails or the end behavior for our graph. So now what we want to do, let's see if we can find the y-intercept. Y-intercept is when we plug in 0 for x. So if we plug in 0 for x, looking back at our original, that will be non-existent, and so will that term, if you put 0 in there, so you get -9 over -16, which is 9/16. So 9/16. I'm going to zoom in to graph that. It's a little above half. All right, let's figure out what our graph looks like here. To the left of the vertical asymptote. So looking to the left of this vertical asymptote, there's really only one option for our graph. It cannot be down here. It can't be down there because it crosses the x-axis and we know there is no 0 there, which means it has to be up towards the top here. So we're going to just graph this, making sure it's approaching both the slant asymptote and the vertical asymptote. If we wanted to be more precise, we could plug in a value for -5 or -6. Coming to the right of that vertical asymptote, we actually know this next part for 2 reasons. Vertical asymptotes factors with odd multiplicity will be on opposite sides of the x-axis. And multiplicity comes from, we're talking about -4. The exponent is 1. 1 is odd. And so our graph is going to be on opposite sides of the x-axis. So to the left, it's going up. So we know that to the right, it's going down. So we can graph this here. It's got to hit this 0, which is another reason it has to go down. It's going to hit the y-intercept there at 9/16. It will go through that other 0, and then it will get closer and closer to the slant asymptote. And that is the graph of our function.